Huh?
Well, then we are back to this class, and this is lecture number 15 on refraction by prism. And what we were discussing in the previous class, which got disturbed, we were discussing the basic formulation or basic about prism. We were discussing the angle of deviation. I can't see you, but I hope I can hear you. So we are discussing angle of deviation. It is there on your boards right now. I hope you can see this. Angle of deviation, the total angle of deviation delta is nothing but equal to delta 1 plus delta 2. Now if I put the value of delta 1, if I put the value of delta 1, which is here, and delta 2, which is here, I will get the value of the total deviation of this prism. Remember, this is the incident ray PQ. RS is the emergent ray. Angle of deviation is the angle between the incident ray and the emergent ray for a prism. Do we understand this? So if I put the value of delta 1 from equation number 1, delta 2 from equation number 2, I will get the value of delta, which is the total deviation. It will be equal to I1 plus I2 minus R1 plus R2. Do we see this? Can I have some raise hand? Oh, I can have some raise hand. Can you tell me that you understand this angle of deviation? Delta, total angle of deviation, which is my equation number 4, will be equal to I1 plus I2 minus R1 plus R2. I hope all of us are able to understand this. Can you hear me? Can you see me? Can I have some response? I think the volume, the mic has also gone and I can't see you. But I hope that you have understood this. I will try to show you from your sheet as well. It is very well described in the sheet that I have sent you, and right now it comes on the bigger screen. Delta, which is the total angle of deviation, is delta 1 plus delta 2. If I solve it, I will get I1 plus I2 minus R1 plus R2. Do we understand this? I'll give you a minute to note this down. Let me now take you again back to this diagram, a bigger one now. Now you see, this is an angle theta given over here. Do you see this angle theta? Which is nothing but angle QOR. Do we understand this? Angle QOR is angle theta. Yes or no?
Yes, sir.
Angle QOR is angle theta. And if you look closely at the triangle QRO, for this reason, I have shown you this diagram on the bigger screen. In the triangle, in the triangle, in the triangle QRO, R1, R2, and theta are the three angles of the triangle. So I can write R1 plus R2 plus this angle theta is nothing but equal to 180 degrees. Do we understand this? That is the next point.
Yes, sir.
Important point number 5 that you will have to note down, that R1 plus R2 plus theta is equal to 180 degrees. If when a question comes in the examination hall, it can come in different ways. If you can remember all these important points, point number 1 was the value of delta 1, point number 2 was the value of delta 2, Point number 3 was delta is delta 1 plus delta 2. Point number 4 was the value of delta in terms of I1 plus I2 minus R1 plus R2. This is point number 5. R1 plus R2 plus theta is 180 degrees. Please note it down. I'll give you a minute to note it. Let me move further ahead and bring your attention to a quadrilateral now. And which quadrilateral I am talking about? Quadrilateral A, Q, O, and R. A, Q, O, and R. And I will not. Okay, let me put it in red so that you can see. A, Q, O, R. Do you see this red quadrilateral, bacha? Do you see this red quadrilateral? In this red quadrilateral, angle A and theta are opposite angles. Yes or no?
Sir.
So from this quadrilateral, beta, I can write my point number 6. Point number 6 from this quadrilateral. Angle A plus angle theta, opposite angle of a quadrilateral, opposite angle of a quadrilateral is always equal to 180 degrees. You must have read about this in your 9th standard or 10th standard, wherever you have heard about quadrilateral. Angle A plus angle theta, opposite angles of a quadrilateral are always equal to 180 degrees. Do we understand this? This becomes my equation number 6. Number 6. Number 5 was R1 plus R2 plus theta is 180. Number 6 is A plus theta. Please draw the diagram on one big sheet so that you can write everything that I'm telling you on that sheet itself. With that one sheet of Prism, you would be able to solve almost all of the problems that are going to come, beta. I'll give you a minute. This is the last thing that I wanted to show you from the diagram. After this, we may not need the diagram at all. It's more about maths and it's more about remembering. So this is the last time probably that you are going to see this diagram. Mark all the things. I will give you a minute to do it. Equation number 5 and equation number 6. Equation number 5 is telling me R1 plus R2 plus theta. R1 plus R2 plus theta is 180 degrees. That is my equation number 5. Equation number 6 is from the quadrilateral AQ, or I have shown you the quadrilateral. It is A plus theta is equal to 180 degrees. Now we can easily derive from equation number 5 and equation number 6. Equation number 5 is also equal to 180. Equation number 6 is also equal to 180. So both of these equations must be equal. R1 plus R2 plus theta must be equal to A plus theta. Theta will get cancelled and I will have my equation number 7. R1 plus R2 is equal to prism angle A. This is my equation number 7. Equation number 7 is not a different equation. It comes from equation number 5 and equation number 6. From equation number 5 and equation number 6, I can derive that R1, which is the angle of refraction on the first surface, R2, which is the angle of incidence on the second surface, R1 plus R2 is equal to the prism angle A. I hope it is clear to all of you. I'll give you a minute to note this down in your notebooks. Well, now let us move ahead. I hope you have noted down. Let us move ahead and move on to my equation number 8. What is this equation number 8? This is nothing but I have just put the value of R1 plus R2 in equation number 4. Please have a look at equation number 4. In equation number 4, delta, the angle of deviation was I1 plus I2 minus R1 plus R2. In place of R1 plus R2, I have put A. That gives me another form of equation number 4, which is now equation number 8. Equation number 8 is total angle of deviation total angle of deviation delta is I1 plus I2 minus the prism angle A. Am I clear with this? Can I have some? Can you let me know that we have understood this? The total angle of deviation, the where the spelling of deviation is wrong. Deviation. The total angle of deviation is I1 plus I2 minus A. I'll give you a minute to note down equation number 8. Let's move ahead to the last set of equation, not the last set of equation,
Yes,
but
sir.
the next set of equation on this. Now what I'm going to do is I'm going to apply Snell's law. See, I'm giving you so many equations, but in the exam only one of these will come and one of this will surely come. You can just go through this equation when you are back at home. That will give me a lot of confidence. So now if I apply Snell's law at surface AB, this is Snell's law. Mu into sine of I is a constant. So mu1 into sine of I1 is equal to mu2 into sine of R1. R1 is the angle of refraction on the first surface. I hope you understand this. Similarly, I can write mu2 into sine of R2 is equal to mu1 into sine of I2. Do we understand this? So this equation might be called as equation number 9 and this equation might be called as equation number 10. Do we all understand this? It is very simple. Just applying Snell's law. Mu into sine I is constant. Mu1 into sine I1 is equal to mu2 into sine R1. I hope it is clear to all. I'll give you a minute to note it down. What we can do is from equation number 9 and equation number 10, I can make equation number 11 if I want to. I'll just find out the value of mu1 by mu2 from both sides and I will equate. In short, I will get equation number 11 sine of I1 divided by sine of R1 will be equal to sine of R2 divided by sine of I2. A very important result. A question can come directly from this point. They will give you any three of the angles and they will ask you to find out the fourth angle. You can just find it out from here. Sine of I1 divided by sine of R1 should be equal to sine of R2 divided by sine of I2. Do we understand this? Or I have written the equation wrongly, I think. It should be sine of I2 divided by sine of R2. Sorry, I have just written it wrongly. I will just correct it. Genuine mistake. Sine of I2 divided by sine of R2. Do we understand this? Yes or no? Sine of I1 divided by sine of R1 is equal to sine of I2 divided by sine of R2. A very important result. They will give you any three angles. They will ask you to find out the fourth angle. I'll give you a minute to note it down. So now we move on to the next important condition here in this particular chapter, in this particular topic, refraction by a prism. It is the condition of minimum deviation. Now, what do I mean by condition of minimum deviation? I will show you by a diagram here. If I can enhance this diagram and show it to you on the bigger screen, you would probably understand what is minimum deviation. I should have shown the diagram first. Then I should have taken this. But anyways, everything is good as long as It is done. Okay. Now, instead of writing the after the heading condition of minimum deviation, the first thing that you can do is draw this diagram. Now, what is this diagram? This diagram is a graph between angle of incidence I, which is I1 on the first surface, and between delta, which is the angle of deviation. So this is a graph between at what angle the light is falling on the prism and what is the angle of deviation. Now what do I see is when I increase the angle of incidence on the first phase, which is I1, the angle of deviation decreases and it gets to a minimum value at some point, and at that point we have minimum deviation. What is the condition for minimum deviation? My angle of incidence I or I1 becomes equal to the angle of emergence I2, or I can call it as E. Remember, I told you that I2 is also known as E, which is the angle of emergence. So in this case, what happens is the ray deviates by minimum angle. This angle of incidence is known as the angle of incidence for minimum deviation. So if I change the angle of incidence at the first surface of the prism, the angle of deviation decreases. When angle of incidence increases, initially the angle of deviation decreases. It goes to a minimum value and then it raises up at the minimum value. The angle of incidence and the angle of emergence is equal. Do we understand this? Yes or no? I'll give you a minute to note it
Yes,
down.
sir.
Please draw this diagram and write I1, which is the angle of incidence on the first surface, is equal to I2, which is equal to E, the angle of emergence on the second surface. Now we will write the conditions for minimum deviation. For minimum deviation, the first and the only condition is refracted ray QR should be parallel to the base of the prism. Please note this down. The refracted ray QR, you saw that refracted ray QR. If that refracted ray QR is parallel to the prism ka base, remember prism was in triangular shape, one refracting surface, second refracting surface, and then we had a base. If my refracted ray is parallel to the base, we will get minimum deviation. Now, if that thing happens, the refracted ray is parallel to my base, my angle of incidence I1 will be equal to the angle of emergence, whether you call it as I2 or you call it as E, they both become equal. Do we understand this? Can I have some raised hand that we understand this? I1 and I2, angle of incidence and angle of emergence become same. That is the second point. It is coming from point number 1 only. The third point is angle of refraction on the first surface R1 and angle of incidence on the second surface R2. They also become same. R1 becomes equal to R2 because this ray is parallel to the base. Now R1 plus R2 is equal to A, and R1 and R2 both are same. So I can write the value of angle of refraction R on the first surface is equal to A by 2.
A by
This
2.
becomes your fourth condition. Do you understand this, beta?
Yes, sir.
Well done, sir. This is R1 plus R2 is equal to A. R1 and R both are same. Let me call both as
A
R.
to R is equals to A. R is equals to A by 2.
R is equal to A by 2. That is correct. Please note it down. I'll give you a minute.
Okay, sir.
Okay, then. Minimum deviation. The spelling of deviation is wrong, but we can make it right. For minimum deviation, it is the angle of deviation is always I1 plus I2 minus A. I1 and I2 both are same here. So I can write the formula for minimum deviation as 2I minus 1. It is very simple. You can call it equation number 5 for minimum deviation. Equation number 5 for minimum deviation. From this equation number 5, I can find out the value of I, and I will be equal to A plus minimum deviation by 2. You can call this equation as equation number 6. This is already my equation number 4. So 4, 5, and 6, all the three equation at the same time. Do we understand this? I'll give you a minute to win it.
Okay, sir.
Then let us move on to the next part. If this prism is placed in air, mu1 is equal to 1. That simple as that. You may not remember this, you may not remember this. These are all derivations, nothing else. But you have to remember the value of mu. Oops. The value of mu is sine of I1 divided by sine of R1. Do we understand this? And here I have just put the value of I1 and R1 from the equation number 4 and equation number 6. I1 or I is A plus delta minimum by 2. R is A by 2. I have put the value and I have got this very important equation. Mu, the refractive index of the prism, is equal to sine of A plus delta minimum by 2 divided by sine of A by 2. Do we all understand this? Yes or no? No, yes.
Yes, sir.
Please note it down, beta, in your notebooks.
Okay, sir.
We move on to the next point, and this is a very important point. I have seen straight away questions coming from this point in JEE as well as in NEET. If the angle of prism is small, less than say 10 degrees, or even not 10 degrees, maybe 4 5 degrees, normally it is 4 to 5 degrees, we can take the value of sine theta as, for very small angle, sine theta is same as theta. Both should be in radians, not in degrees. So sine of 10 is not same as 10. Sine of 10 radians is equal to 10 radians. Remember, this theta must be in radians. Do we understand this?
Sir.
Okay, this theta must be in radians. Then what we can I do? From the previous equation, which is equation number 7, the value of mu, instead of it becoming sine of A plus delta minimum by 2 divided by sine of A2, sine is taken out and instead we only have angles. So it simply becomes A plus delta minimum by 2. This is equation number 8. But remember, this is only possible when the angle of prism is taken to be very small. From here, I can get this very important result, equation number 9. It is as important as the previous result. The previous result was valid for any type of prism. This result number 9 is valid only for prism with small angle of prism angle A. So remember, equation number 8, which is same as equation number 9. In equation number 8, I have given you mu as A plus delta minimum by A. In equation number 9, I have given delta minimum as mu minus 1 times A. This is a very important result that you should never forget. Please note it down. I'll give you a minute to note it down. Then here is a summary of what we have read about Prism. We'll just quickly go through it. You can just mark it in your sheet. From your sheet, you can just mark it. Angle of prism or refracting angle of the prism is the angle between the two faces where refraction is happening. If the faces of prism on which the light is incident and from where it is emerges are parallel, then the angle of prism would be 0 and incident ray will emerge parallel. The angle of deviation will be 0. So this prism will not be a prism, but it will act as a transparent plate. For a prism to act as a prism, the two refracting surfaces must be at an angle. They should not be parallel. Do we understand this? The third point is if the refractive index of the material of the prism is same as that of the surroundings. So if I keep a glass prism inside glass or a water prism inside water, there will be no refraction and hence the lights will pass undeviated. The angle of deviation delta will be 0. Do we understand this? Can I have some raised hand that we understand this? You just let me know that you understand this. I'll give you a minute to note these points down. Well, then I will just move on. And since there were so many formulae, I thought that it would be better if I can write all of these down and we will revise them together. Even I forget them. So we will revise them together. The first formula was formula for delta 1. Then write it now. Delta 1 is I1 minus R1. Do we remember this? The second formula was the formula for delta 2, that will be equal to I2 minus R2. The third formula that I gave was the total deviation delta, that was delta 1 plus delta 2. The fourth one, the fourth one, the fourth one. The fourth one came from the third one and the first one and the second one. We put the values of delta 1 and delta 2 from equation number 1 and 2. In equation number 3, I get the value of delta. In equation number 4, that is I1 plus I2 minus R1 plus R2. So far, so good. Is everyone there with me? Can I have a confirmation that everyone is following me? Up to
Yes,
formula number
sir.
4. Yes, done. Well done. Then from formula number 5, we went on to that triangle and that quadrilateral. From that triangle, if I remember, it's QRO, I think. R1 plus R2 plus angle theta was 180 degrees. That was formula number 5. Let me just make a line here so that I can continue. Okay. Formula number 5. Then my formula number 6 was from the quadrilateral or trapezium. A plus theta was equal to 180 degrees. That gave me my formula number 7. R1 plus R2 is equal to angle A. I hope everyone is following me. Yes or no? No or yes?
Yes, sir.
Then in formula number 8, what did I do? I did nothing. I just put the value of R1 plus R2 from formula number 7 into formula number 4. So my formula number 8 becomes I1 plus I2 minus A. A very, very important formula. It relates the angle of incidence and angle of emergence with delta. This formula is valid for all types of prism, whether they are small angle or whether they are big prism, big angle. Then we went on to formula number 9, mu1 into sine of I1 is equal to mu2 into sine of R1. Then from here, formula number 10, mu2 into sine of R2 is equal to mu1 into sine of I2. From equation number 9 and 10, I can get number 11, which is sine of I1 divided by sine of R1 is equal to sine of I2 divided by sine of R2. I hope everyone is following me. Yes or no? No or yes?
Yes, sir.
I hope everyone is noting it down. This was the formula for prism, whether they were prism of small angles or prism for large angle. What was the next thing that we did? So we'll continue on this journey, and we will write the next set of formulae, and the next set of formulae were for minimum deviation. Do we remember this minimum deviation? Yes or no? No or yes? The refracted ray must be parallel to the base of the prism. Yes or no? No or yes? Do we remember this?
Sir.
Then the next formula becomes I1 is equal to I2 becomes equal to I. All of the angle of incidence and emergence is same. Yes or no? No or yes?
Sir.
R1 becomes equal to R2 becomes equal to R. Angle of refraction on the first surface and angle of incidence on the second surface become same. From here, I derive that R will be equal to A by 2. Yes or no? No or yes?
Sir.
But again, remember these formulae are only valid for minimum deviation, minimum deviation, minimum deviation. Then I can write minimum deviation delta mean is 2 times I minus A. Do we remember this? Yes or no? No or yes? Equation number 6 can be written as the value of I will be equal to A plus delta minimum divided by 2. Is everyone following me, or have I gone so far ahead in life that no one is seem to be following me? Yes or no? No or yes? Everyone there with me?
Yes, sir.
Okay, I hope everyone have noted down till this point. I'm giving you a minute while I'm just changing the screen to note it down. Then I had the formal formula for what? The value of mu, and the value of mu was sine of A plus del min by 2 divided by sine of A by 2. Do we remember this formula? Yes or no? No or yes? Yes, sir. Then I moved
Sir.
on to small prisms. Yes or no? No or yes. The angle of prism is less than 10 degrees. So sine of theta becomes approximately equal to theta. Remember, in radians, not in degrees. Then I have this amazing formula. This amazing formula is only valid for small prisms. The value of mu for a small prism becomes A plus del min divided by A. Yes or no? No or yes? From here, I can find the value of delta minimum for a small prism. Delta minimum for a small prism is mu minus 1 times A. I will give you a minute. I'll give you a minute to go through all these formulas, because based on these formulas, we are going to move ahead and solve a couple of questions so that these formulae become clear in your head. I'll give you 2-3 minutes. Go through this entire thing so that you are ready to solve questions. 2 minutes is what you get to revise these formulae and solve some problems, sir. And this is the first problem, which is from your sheet only, problem number 23. Let's see who solves this problem for me. A glass prism of refracting angle 60 degrees gives a minimum deviation of 30 degrees. What is the refractive index of glass? Uh-oh. Can you solve this problem for me, everyone? I'll give you a minute to think about it.
Okay, sir.
You solve this question. The answer to this question lies in which equation? Lies in which equation? Equation number 7. Do we remember this equation number 7, everyone? Mu is sine of A plus delta minimum by 2 divided by sine of A by 2. Do we remember this, bacha?
Sir.
So, what do I do now? I just write mu is equal to sine of, what is the angle of prism given here? What is the angle of prism given here? It is 60, bacha. 60. The minimum deviation is 30. 60 plus 30 divided by 2 divided by sine of angle of prism 60 divided by 2. Now it is very simple. Now it is very simple. Now it is very simple. This is sine of 45 degrees divided by sine of 30 degrees. Yes or no? No or yes?
Yes, sir.
Sine of 45 is 1 by root 2. Sine of 30 is 1 by 2. 1 by root 2 divided by 1 by 2. 2 will go on top. Root 2 will cancel 1 root 2. And your answer will be root 2. Yes or no? No or yes? Yes or no? No or yes? Your mu will be equal to root 2. Do we all get this answer?
Yes, sir.
Then I must congratulate you. You have done great job if you could solve this question in the first attempt. Remember, whatever questions will come, they will come from whatever we have discussed in the class. You will not get a question where you will have something which is not discussed in the class. Having said that, let us move on to the next question. Are we ready for the next one?
Okay, sir.
Yes, sir. Everyone looks excited. I can't see but I can hear the excitement, and I am excited too to present to you the next one. And the next question is this. When a ray of light is refracted by a prism such that the angle of deviation is minimum, then you have four options, A, B, C, D. You have to tell me which one is the correct option. And I'm waiting for your answers. Which is the correct one? I'll give you a minute to think about it. And yes. The correct answer is option A. We have already discussed it. The condition for minimum deviation. Can you tell me, Bacha, what was the condition of minimum deviation? There was only one condition I told you. What was that one condition that I told you? What is what? The refracted ray becomes parallel to the base of the prism. Do we remember this? And in that case, angle of incidence and angle of emergence become same. Angle of refraction R1 on the first surface and angle of incidence on the second surface R2.
I1 is
They
equals to
also
I2.
become same. I1 is equal to I2, R1 is equal to R2, R is equal to A by 2. If you remember this, you will be solving this problem. Shall I move on to the next one?
Sir,
Yes, sir. Then, sir, let's see, sir, who can solve this one, sir. If the angle of the prism is 60 degrees, the minimum deviation is 40 degrees. What is the angle of refraction? Oh, oh. Angle of minimum deviation is given as 40 degrees. The angle of the prism is 60 degrees. What will be the angle of refraction? Can I have your answers, please?
A.
A is the right answer. A is the right answer. How did you get it, bacha? How did you get it? Remember, when the deviation is minimum, your angle of refraction R is equal to A by 2. Angle of prism divided by 2. Do we remember this formula? Do we remember this formula? Do we remember this formula? Yes or no? No or yes? Can I have some clarification that angle of refraction R is equal to A by 2 for minimum deviation. Angle of prism here is 60 degrees, 60 divided by 2, and the answer is 30 degrees. Do we understand this? That will take me probably the last question for today. And the last question for today goes by this. This is question number 28. I hope everyone can see this. Question number 28, coming to on your way now. The refracting angle. When I say refracting angle, I mean angle A. The refracting angle, angle A is 40 degrees. Angle of incidence is 38 degrees. It is given as minimum deviation.
sir.
Yes, beta?
Hi.
The ray passes in the position of minimum deviation. What is the value of minimum deviation? Can I have your answers, please? Can I have your answers, please, bacha? I have to give the value of minimum deviation. Angle of incidence is given and the prism angle is given. You must be able to find out. You must be able to find out the value of minimum deviation. Yes or no? No or yes?
Yes, sir.
Which formula will you apply here, bacha? Please tell me the formula. Which formula will you apply here?
हेलो आवाज आ रहा है सर? आपकी क्लियर है, मेरी वॉइस क्लियर है? हाँ क्लियर है। ओके ओके सर।
Okay.
जो मैं
Please.
जाना
Is everyone there here with me?
अभी क्लास हो गया सर, जानो कुछ पोस्ट बनाता हूँ, जानो।
Okay. Which formula will I apply here? This is formula number 5. Do we remember this? Minimum deviation is 2 times I minus A. So I multiply 2 by the angle of incidence, 2 into 38 minus 40. 2 into 38 is 76. 76 minus 40. And your answer is simply 36 degrees. Option C. Do we understand this? Yes or no?
Yes, sir.
Well, I got some disturbance from somewhere in between. Some maybe class was co-connected with us. Anyways, this finishes this part of the chapter where we did some
No,
questions
sir.
on
Geology class
prism.
start हुआ है, sir.
Okay, we will wind up our class here. I hope you enjoyed this class. I'll see you tomorrow. Take care. Have a nice day, bacha. May God bless you all.
Bye, sir. Take care, sir.